Alright, so here we go with laws of exponents, which I expect to see the next time I see y'all. Hopefully tomorrow. Anyways, so we're going to utilize the laws of exponents to apply expressions. This is actually should be a review from Algebra 1. From what I saw in the book, there's really not much that covers this because they expected all this to be something you should remember from Algebra 1. So this is more of like a refresher course than it should be, say, learning something new. Anyways, so first off, let's talk about this. Let's talk about Mattman. What is Mattman? Besides a very bad superhero name, what Mattman is this. It's like a what is that word where you're creating a thing to help you memorize a mnemonic device. So what does it mean? It means this: when you multiply, you add the exponents. When you have parentheses, you multiply the exponents. And when you add, you'll do nothing with the exponents. That's just like combining like terms. So if I say x squared and x squared, I get 2x squared. I don't get x to the fourth. Anyways, so the main part there is focusing on the multiplying in parentheses. So let's get to our first set of examples. Alright, so I've got x to the 7th times x to the 4th. Now what that means is, again, notice there's your multiplication. I am multiplying these two, which means I am supposed to add the two exponents. So I'm supposed to say 7 plus 4, and 7 plus 4 is 11, so my answer is x to the 11th. Here's some more multiplying. Notice they're all multiplying here, so that means I should add all three exponents and get m to the 10th. 3 plus 5 plus 2 is 10. There's another way I can show this, but I'm going to wait till the next set of examples because I don't want to confuse things. Now let's look at the parentheses. What does it mean by parentheses? What that means is this, and I'm going to give you two examples here. The first one, what that means is, like, first off, make note of the exponents right here. Okay, the exponents on this exponent on the outside will multiply. It's almost like distributive property. The exponents on the inside. So I'm saying, notice I put a 1 with that 4. So I'm now saying this is 4 to the 3rd power, x to the 9th power. 3 times 1 is 3, 3 times 3 is 9. Now, 4 to the 3rd power, I would like y'all to actually fill that out, finish it out, is 64. So the answer here is 64, x to the 9th. Whoopsie, I think I should have put a little exponent on that next one. There we go. So now here, I'm going to say 5 times 2, because that's a 2, 5 times 4. So now I'm saying 5 times 2 is x10, and 5 times 4 is y20. So then the answer there would be x10, y20. Now, the reason why I bring that up is because that's a little different than that one. That parentheses, notice there's exponents on the outside that are by themselves. They're lonely, so they go and join the others. But here, this is not by themselves. There is no exponent out here by itself. So when this is the case, all you're supposed to do is just straight multiply. Like say 2 times 3 is 6. And then with the exponents, since this is multiplication, you add x7. And there's your answer. Okay, so notice the difference between those two and make sure you pay attention to that. Alright, so the next part is the 0 property. Anything to the 0 power is equal to 1. So notice here, x to the 0, 1. 7,234 to the 0, 1. X cubed, y to the 4th, z to the 5th, all that to the 0 power, 1. Anything to the 0 power equals 1. Just a reminder, anything to the 0 power equals 1. Okay, division exponents. Negative exponents. Negative exponents, we want to deal with reciprocals. So we want to do reciprocals. We don't want negative exponents. We want to make them positive powers. So if you see something like this, -6 to the -3, you flip it. 1 to 6 over 1 over 6 to the 3rd power, which is 1 over 216. Notice here, the positive one on this one, the positive one stayed on top, but the negative one went to the bottom. So basically, a negative exponent is going to make it switch positions. If it's on top, it goes to the bottom. If it's on the bottom, it will go to the top. And that's about it for that one. This is all, like I said, should be reviewed. Now, division property. Division property is the exact opposite of the multiplication. When you multiply, you add. When you divide, you subtract. So, That's what that's going to say. So you subtract the exponents. So when you're dividing, you subtract the exponents. Now keep in mind, where does the positives go and stuff like that. So if I say something like this, here I am saying like x to the fifth, y to the third, divided by x squared y, put an exponent of 1 here, and I'm saying 5 minus 2 is 3, 3 minus 1 is 2, and I'm done. What happens if I do something like this? H squared b to the fifth, you get all that, you can see it. Okay, c to the fourth. Now I'm going to say 2 minus 6 is negative 4, 5 minus 3 is positive 2, and 4 minus 4 is 0. Okay, anything to the 0 power equals 1, and that a to negative 4 needs to move to the bottom because it's negative. I want to make it positive. And there would be your final answer. So that's pretty much, like I said, a fairly quick review. We're going to try to do quite a bit of extra work with this to get you ready for the test. This is going to be short and sweet, so keep in mind that the next part will probably put a lot more emphasis on the word problems. But anyways, that's it for today. Thank you very much, and I expect to see these notes next time we see you. Thank you.